again, if we talk things through and we look at things, we have to decide, do we have, I always like, quotient rule is sort of like the first one. Do you have a quotient rule? If yes, you do your quotient rule. Then you look, do we have a product rule? Do we have chain rules? So here, I have a quotient rule. What am I going to do with the quotient rule? I'm going to keep the bottom the same. So I'm going to keep that square root of x to 5. Multiply by the derivative of the top. And when I do the derivative of the top, the derivative of 2 is 0. And here I have a chain rule with negative natural log of 4x. The outside function is the natural log of x. So its derivative is 1 over x. So I would have 1 over, keep the inside the same, 4x. Multiply by the derivative of the inside times 4. Subtract, keep the top the same, and multiply by the derivative of the bottom, and then we square the bottom, which just becomes x to the 5, because squaring that square root would go away. But you can leave it as x to the 5 over 2 squared if you want to. In AP, you do not have to simplify unless they explicitly say they want it in a certain form. So we can leave all of our derivatives looking like this, which is really nice. Have you been practicing all your shortcuts? How many do we have right now? 6, 12 or 13? We have 13 shortcuts? Okay. So go through every night. What's the derivative of cosecant? What's the derivative of secant? What's the derivative of tangent? Knowing your shortcuts will make from now till May either easier or harder. Every time you forget a shortcut, you've got to go back to your notes, look it up. It takes too much time. Get to know your shortcuts very well as quick as possible. And I'm going to tell you some of the trig ones that we don't use as much are going to be easy to forget. So again, make a list. Maybe break it up. I would break it up into like, what are our 3 main ones? Product rule, quotient rule, chain rule. Those are like 3 main ones where things stay the same and things change. Then there's like power rule, ln x, 5 to the x, e to the x. 6 trig functions, so those are easy to group together. I was counting, and I was using one hand, and I forgot where I was. I think. 13 or 14. Okay. Do we have, of the 3 big ones, do you notice that we have the quotient law? Okay. You can always, if you really despise the quotient law, you can always replace the quotient law with a power rule, chain rule combo. Because what could I do with what's on the bottom? I can move it to the top by adding an exponent of -1. And if I moved it to the top, I'd have a product rule instead of a quotient rule. But the exponent of the -1 would also add another chain rule. So in this case, it is probably better to keep the quotient rule. What do? We keep the first one the same. And the derivative of cos is negative sine. Keep the inside the same. Multiply by 3. How do you know when to use the chain rule? Whenever your inside function has its own unique derivative. If your inside function is just an x, its derivative would be 1. You don't have to do a chain rule. But anything other than that, like here I have a 3x, it has a derivative of 3, I'd have to do a chain rule. Then we keep the top the same. And multiply by the derivative of the bottom. Again, I have a chain rule here. So I do the outside function's derivative, which is cos. Keep the inside the same. And then multiply by the derivative of the inside. And that 1 over the square root of x, I probably would have already changed that to write it as x to the -1/2. So it's in my power rule form. If I changed it to x to the -1/2, you see it's really easy to see that I brought the -1/2 out in front. subtracted 1 from the exponent. Over the bottom, all squared. I like putting the brackets and the squared outside. Do you see you could have written the 2 there instead? That would have been perfectly fine. F of x equals 2 sine cubed x minus 3 sine x. And we want to show that f prime of x is negative 3 cos x cos 2x. So first of all, we'll just do the derivative straightforward. Do you see that this is a chain rule? That the sine x is inside being cubed. The outside function would be the cubed, sine x would be the inside function. So we bring the 3 out in front, keep the inside the same, subtract 1 from the exponent. Multiply by the derivative of the inside, which is cos. Then the derivative of negative 3 sine x would be negative 3 cos x, because the derivative of sine x is positive cos x. And from here, we need to make it look like this. Now, if you get a question, and this is true of multiple choice, okay? Multiple choice is often a show that kind of question, except you found your derivative, and now it doesn't look like any of the 4 answers in the multiple choice. You have to do some sort of manipulation, okay? One of the things that can sometimes be a hint. The answer can be a hint of what you should maybe do. So what I notice here in my answer, I notice it has a cos 2x, and I don't have a cos 2x anywhere in mine. But I did notice this negative 3 cos x. That's a hint. Maybe I should factor that out. At least something matches with the answer. So I factor out a negative 3 cos x, not just a 3 cos x. Like 3 cos x is in common, but because my answer had the negative, I'm like, okay, I'll take the negative out. Then what am I left with in brackets? I'm left with negative 2 sine squared x plus 1. And since it's supposed to be a cos 2x, I'd go to my memory, and my memory would say, oh, Mr. Jerry, forgot your double angle formulas. Better look at your formula sheet or up on the wall. Right? But on the exam, you'd have to have those ones all 3 memorized. Right? Or on the exam, you go, I have to show this. I better hope that this matches up, and just write it and cross my fingers that I didn't make another mistake along the way. Solve for k. 3 to the x equals e to the kx. Okay? And then we're going to use this to show one of our shortcuts. Right? We already know this is a shortcut. The derivative of 3 to the x is 3 to the x ln 3. But if I make 3 to the x e to the kx, and I solve for k, well, how would I do that? Well, I could take the natural log of both sides of those equations, because I'm solving for an exponent. And you need logarithms to solve for an exponent. Once I take the log of both sides, what does that allow me to do? Oops. It allows me to bring the exponents out in front. Remember that log law? That your exponents could come out in front? If I divide everything by x to get rid of the x completely, then I get that k is equal to the natural log of 3. Which means every single base, if you wanted it to, could be written as a base of e. And with that, how do I do the derivative of 3 to the x? Let's say I didn't know the shortcut and I wanted to prove it and I was allowed to use e to the x. Well, if I do the derivative of this, it's a chain rule. The outside function is e to the x. The inside function is ln 3 times x. What's the derivative of e to the x? It stays the same. Multiplied by the derivative of the inside, which would just be the ln 3. But then what was this? That was 3 to the x originally. So this is sort of like using the chain rule to prove one of our shortcuts. Three to the x is equal to this. So I started with 3 to the x, I replaced it with that. Then that got to be the same, so I could replace it back. All of those things in those green boxes are the same all the way through. I just changed the formatting so I could do the derivative. Find the gradient. Gradient is another word for slope. Slope of a tangent is another word for derivatives. So if I want to find the slope of the tangent, I should find the derivative. What kind of rule do I have here? You see the product rule. So we keep one the same. Multiply by the derivative of the second one. When I do the derivative of the second one, do you see that it's a chain rule? That you have a 1 minus 2x inside of a power of a half. So how do we do the chain rule? Exponent out in front, keep the inside the same, subtract 1 from the exponent. Then we multiply by the derivative of the inside. Then keep the second one the same, multiply by the derivative of the first one. The negative 1/2, you can move that to the bottom. Sometimes they ask you to add these fractions together. So you would need to get, and I'll show it here, I would need a common denominator, so I multiply this one by my square root of 1 minus 2x and square root of 1 minus 2x to get that common denominator if I wanted to add those fractions. And it works out really nice and simplifies really nice. Now that I have it simplified, I could just plug in my negative 4. And I could find my slope of my tangent. Just a reminder, you could also find the slope of your normal, which is important for B because it says find the equation of the normal line. And the two things you need to find an equation are the slope, which we have from part A, and we need a point. And we could find a point by just plugging in negative 4. There's our slope, there's our point, there's our equation. On the AP exam, I would leave it like that. I wouldn't simplify it. If you simplify and make mistakes, you could lose marks. If you don't simplify, the chances of making a mistake after not simplifying are very rare. If you really love y equals mx plus b, you could change it. So again, I've been putting up all the videos, but if ever you just missed something in the notes, I also posted the notes on Teams. And I've been posting solutions. I just posted yesterday's vertical surfaces activity, which we're going to continue today. I posted the questions and the solutions on Teams, so there's lots of things available on Teams. Answers to, I think, the solutions to multiple choice questions on the first take-home quiz. You know those, there were some tough ones on there. Not only are the answers on Team, but how to do all of them. So when you're studying for your test, which do you, I know that you heard rumors, I haven't put it up here. Do you know what it is? Next week, Thursday, which is November the 13th. That's the earliest we can do it because Monday's Remembrance Day. That affects our class. Tuesday is Remembrance Day. That affects our class again. Wednesday is the math contest day, which affects Mr. LaFrance's class. And Thursday, nothing. So that's our test day. But that gives you lots of time to study and prep before that. You have take-home quiz number 2 due today, which means I will give you the last one. Here, I'll put up. We'll explain our next question. You can write it down. So here, you see that you have a product rule. So I keep the first the same. Derivative of the second. The derivative of the second is a chain rule because inside, the derivative of the inside is a -1. Then keep the second one the same, derivative of the first one. And now we need to make it look like this. This has square roots in it, so I'm going to change my x to the -1/2 back to a square root. I notice the bottom has a 2 root x. So this one here, which is over 1, I'm going to multiply it by 2 root x and 2 root x to get that common denominator. That works out really nicely because then on the top my root x has become an x and 2 times -2 becomes a 4. And now I can just expand and simplify or factor out a 3 minus x to get the answer. This last take-home quiz is all multiple choice. Kind of weird. The second one had no multiple choice, right? And then this one is all multiple choice. I'm actually going to give you a bubble sheet for this one to fill in. Because then it can get, the whole thing can get marked instantaneously. But if I give you the bubble sheet now, look around, you know there will be some people in this class that will lose. Those, you know who they are. So I'll give it to you. I'll give it to you on Wednesday. You can just fill it in right before you hand it in. Or whenever you're done, you can just come pick one up and fill it in. Then you don't have to actually hand this part in, you can keep it. Let f of x equal g of x over h of x, and they give us a bunch of individual pieces of information. We know g of 2, we know h of 2, we know g prime of 2, and we know h prime of 2. And we want to find the equation of the normal to the graph at x equals 2. So if we want an equation of a normal line, we would need a slope and a point. To find the slope of a normal, we need the slope of a tangent, which is the derivative. So first of all, we're going to find the derivative, And our derivative is a product, it's a quotient rule. We keep the top the same. Derivative of, no, so you keep the bottom the same. Derivative of the top, then keep the top the same. Derivative of the bottom over the bottom squared. And if we plug in 2, that's going to be the slope of the tangent when x is 2. Simplifying this gives us that the slope of our tangent's negative 1/6. So our slope of our normal is positive 6. What do we need for an equation of a line? We need a slope and a point. We've got the slope at 6. Do you see that the point is f of 2 would be g of 2 over h of 2 would be 18 over 6, which is 3. So our point is 2 comma 3. Plug things in. Rearrange it if you like. I'm going to hand out whiteboards to each row so that when we move back into our groups, it's just a little bit quicker. All right, so next example. Oh, this is very AP style. They give you a chart of values. Chart of values for f and g and their derivatives at 1 and 8 are given. And you know that h of x is f of x times g of x. This is product rule, right? Something times something else. So if you wanted to find h of 1, well, it's not a derivative. We just plug in f of 1 and g of 1. So h of 1 would be 2 times 9, which is 18. If you want to find h prime, well, first you're going to have to use your product rule. Product rule says keep the first one the same. Derivative of the second one. Keep the second one the same. Derivative of the first one. And all of those values are on your chart. So you get 14. That is the slope of the tangent line of h of x when x is 8. And now to find that equation of the tangent line, you need a point, which we have by plugging in 8. You have your slope from part B, and you can find your equation of your line. And the next one. So when I have the foggy notation, I sometimes change it to look like that. Again, right, h of x equals f of g of x, and that would mean h prime of x, derivative of the outside function, keep the inside the same, times by the derivative of the inside function. So not only do you have to do chain rule, product rule, quotient rule with all of your shortcuts, you also have to know how to do it in general terms. Once I have this, can I find h of 1? Well, there's my derivative. Now I just plug in 1. H of 1 will be f prime of g of 1 times g prime of 1. So we start filling these things in. I know g of 1 is 2. I know f prime of 2 is negative 4. I know g prime of 1 is negative 3. And I get 12 as the final answer. And last question for today. We've got f of x, g of x, and h of x. And we've got h of x equals the composition. So again, I would take the time to rewrite that. And if I wrote out my derivative of the outside function, keep the inside the same, multiplied by the derivative of the inside function. So it gives me a bunch of points. I need to find the slope of the normal to the curve of h at x equals 3. So I want to find h prime at 3. I need to figure out f prime of g of 3 times g prime of 3. Do I have all of this information? Well, I know g prime of 3. I know g of 3 is 7. G prime of 3 was given as 4. F prime of 7 was given as negative 5. And I can put that together, get the slope of my tangent. And that means I could find the slope of my normal.